I continued to work on this schematic for an ADSR envelope generator. Separated it to have a separate decay phase, so now it has attack, decay, sustain and release. In the original schematic, this op-amp generates the high pulse for the attack and then the sustain level and then also the ground level for the release. And I put these two transistors here which act as switches, and this op-amp is still used on the attack and the sustain level. But then when this comparator switches to negative, these two transistors becomes deactivated, and here this inverting op-amp buffer inverts the negative voltage to positive and lowers it, and this transistor becomes active, and this is the transistor for the release, and it drains the capacitor to ground. This transistor is not used as a switch but as a variable current source, so it drains the capacitor with variable speed, and I made it like that because I wanted to make the release voltage controllable. And now if you connect the voltage source here, the transistor becomes less activated because this is inverting, and the release becomes longer, and that way you can make some steps longer than others. This here uses this diode to charge this part of the circuit with 12 volts only during the attack and the sustain phase, and when the trigger signal goes to ground, then it's going to the release phase and it's just grounded to here. But in this case I'm using these two transistors to switch the attack and sustain phase and the release phase with this one, so I could have just positive 12 volts here all the time, and that can be used to also add voltage control for the sustain level. So because if you add a voltage control for the sustain level here, it will go up also during the release phase. So if you add another resistor here like that, it will stay on during the release, and we don't want that. We only want to control the sustain level with this voltage control. But here if I add it, it will only affect the sustain level, because in the release phase this part of the circuit is deactivated anyway, so you can set the steps with different sustain level using this method. And because I have already used 4 op-amps, I decided to buffer the output with a transistor used as an emitter follower, because I had to add another chip only for that otherwise. So this is the test circuit for the ADSR envelope, and I have connected control voltage sources for the sustain levels and the release from here. If I disconnect them, it's just using the potentiometers as normal. This is the release, and this is the sustain level, and this is the decay phase. So you can have separate controls. This is the attack. So if I connect this to positive 12 volts, the release will be increased. And this is the sustain level, the same thing. have connected the release to an LFO, and the sustain is connected to a sequence on the sequencer which controls an accent. So you see how some steps are now with higher sustain level. Attenuate the effect with the potentiometer to make the accent less announced. And the release time is also controlled with an LFO.